Hi everybody. So for Integrated Math 1, I figured for our first online lesson, we'll kind of backtrack to some of the stuff that we were covering prior to when classes were canceled. And then after this lesson, unless I feel, and we all feel that we need a little more practice on the Pythagorean Theorem, after this lesson and the homework, we'll just move forward to the next section. So I'm going to do a little mini Pythagorean Theorem review with you. I'll guide you through 4 practice problems, and as I mentioned before, there will be a homework assignment that correlates to this review. I'll post everything to Google Classroom, and you will do your homework from Google Classroom. At any point in the homework assignment, if you're confused, I highly encourage you to go back to this video, rewatch certain parts that kind of guide you through how to do these problems. And what I will also do, because I know some of you have mentioned that you don't have scientific calculators at home, what I'm going to do is I will show you how I access a calculator through the device that I'm on. I'm currently on my iPad. You can do this on a cell phone. You can do this on a laptop or desktop. The easiest way to access a calculator, if you have access to the internet, go to a browser, go to Google, and type into Google calculator. And it should bring up a calculator with enough functions to do what we're going to do here. Obviously, if you have a legitimate calculator, a legitimate scientific calculator, use that, okay? So what I'll do is I will show you guys how to do one problem utilizing this calculator, and then what I'll do so that way I don't have to keep exiting out of Notability each time is I will then do the remaining problems just using my calculator that I have here in my room. Okay, so the Pythagorean Theorem, I showed you guys a video that hopefully got stuck in your head so that way you remember the Pythagorean Theorem. It's the following: a squared plus b squared equals c squared. And what we can use the Pythagorean Theorem for is to find missing side lengths in a right triangle. To the best of my ability, I'm going to draw a right triangle. That's pretty good for freehand. A right triangle is simply a triangle where one of the angles is a right angle, meaning one of the angles is 90 degrees. So this little square is often used to designate that an angle is 90 degrees. And the A and the B values are going to be the legs. Those are the shorter lengths in a right triangle. And the C value is going to be the longest length, the longest side in a right triangle. We call this the hypotenuse. C is the, oops, let me rewrite that. C is the hypotenuse. The longest side in a right triangle. So if we don't know one of the sides in a right triangle, we can use this theorem to solve for it. So you'll need to know how to raise things to the power of 2 and also how to take square roots. So I'll show you how to do that in just a moment. So let's read the instructions here. I'm going to do 4 examples. It says find the missing side of each triangle. Round your answers to the nearest 10th if necessary. So for a lot of these on this worksheet, you're going to get decimals. In fact, I think for all of these, you're going to get decimals. They're not always going to work out pretty. So what I'll do is for whatever answer I get, I'm going to show you a few numbers to the right of the decimal point, and then I'll show you what you should get as your final answer when you round it. Okay? First thing that you should do when you're looking at a picture like this, go to the right angle and draw a line diagonally across from that. That's your hypotenuse. That's your C value. That means that the other 2 sides are your A and your B. And it does not matter if I say that the A value is 13 and the B value is 17, or vice versa. I could say this is the B value and this is the A value. It does not matter for the legs. Okay, so I'm just going to go back to writing it how it was. So I've identified all the appropriate sides. The next thing I'm going to do is I'm going to write my theorem. A squared plus b squared equals c squared. Okay, and all I'm going to do for the next step is I'm going to substitute numbers or variables, if I don't know what the value is, for a, b, and c. Well, I know one of my legs, a squared, that's 13. I know my other leg is b, that's going to be 7.7. Notice how I've got exponents of 2 on those. That's because I have exponents of 2 in my theorem. And then the c value, that's where my variable goes. I don't know that one. All right. Well, I've got everything set up. I'm ready to solve. Now, when you're solving for the x squared here, we're going to have to do the exponents first and then add last. Okay? So think order of operations. I need to evaluate 13 squared and I need to evaluate 7.7 squared first and then add those results together. So I'm going to show you how you can do this if you don't have a calculator at home. I'm going to go back to my browser and I am going to do 13 to the power. So do you see to the left of the 0 there's an x to the power y? I'm going to press that, and you see how near the 13 is put like a little box there? That's telling me to now press the exponent, which is 2. And then I hit equals. So that's telling me that 13 squared should be 169. So I'm going to go back. So this is 169. Notice how my exponent's gone because I took care of that. I'm going to bring down my plus sign, and now I'm going to do the same thing for 7.7. So I'm going to go back to my calculator. I'm going to clear it. And I'm going to type in 7.7. I'm going to press this button to the left of the 0, x to the power y. It's going to bring open a little box there where I can type in the exponent, which is 2. And I hit equals. 59.29 is the answer. So 59.29 is what I'm going to write. 59.29. That's what I get for 7.7 squared. And this all equals x squared. The next thing I'm going to do is I'm going to add those two numbers together. So I'm going to go back into my calculator. And I already have 59.29 on my calculator, so I'm just going to immediately hit the plus sign and say add this with 169. Notice it's the reverse order of what's on my paper. That doesn't matter. Remember, addition, the order of the terms doesn't matter. 2 plus 1 is the same thing as 1 plus 2. I can flip the order of the terms and it means the same thing. I'm going to hit enter and get my result. 228.29. 228.29 is equal to x squared. Now, I'm not looking for x squared. I want x. So I'm hoping that many of you, if not all of you, remember that the last step that I have to do is I have to actually get rid of that exponent of 2. To do that, I do the inverse operation, which is taking the square root. Exponents of 2 and square roots are inverses of each other. What I do to one side, I do to the other. These are going to cancel out, and I'm just going to be left with x. And on the left-hand side, I need to take the square root of that number. So I'm going to go back to my calculator. So as you can see, if you've invested in your own calculator, this is going to be a lot easier. I think it's going to be a little more intuitive to use your own. All right, so I think what I need to do here for the Google Calendar, I need to type in the radical symbol first, which is just to the left of the number 1, and then type in the number. And as you can see, it actually shows me what my previous answer was. That's nice of Google to do that. So 228.29, and then hit enter. So it's giving me a really long decimal, 15.109, blah, blah, blah. I'm just going to write a few of those decimals down. 15.109. That's what I'm going to write. 15.109. And then it just kept going. And the instruction said to round to the nearest tenth. That is going to be the value just to the right of the decimal. So I want to round the 1. If the number To the right of the 1 is a 4 or less. You let the 1 rest, meaning you leave it a 1. If it's 5 or more, you raise the score, meaning you make the 1 a 2. I'm looking at the number 0. That is 4 or less, so I'm going to leave it as 15.1, and I'm not going to write any other numbers after the 1. So 15.1 is going to be my final answer when I round it. All right. So that's how to use the Pythagorean theorem to find a hypotenuse. That's what we were finding in that example. To find a leg, which is what we're going to do for number 3, it's more or less the same to start off. It's just you're going to have one additional step that you're going to have to take care of. So for this one, I am going to utilize my own personal calculator. Bear with me. This is a calculator I have not used in some time. I may need to remember how to actually use this. I used this back when I was studying to be an actuary, so it's a little different from a regular scientific. First thing we're going to do, though, is we're going to identify the 90-degree angle, which is where that low red box is. We are going to draw a diagonal from it. There's our hypotenuse, our C value, which we know in this example. That means the other two values are the A and the B values. And again, it doesn't matter if you say that X is A versus B. The legs are the legs. A and B versus A. It doesn't matter which order you write them in. So I'm going to start by writing my theorem. A squared plus B squared equals C squared. And I'm going to substitute values in. The A squared I said was the X. The B I said was the 7.4. I put an exponent of 2 on that. And the C value is 12.8 with an exponent of 2. Same as before, I need to evaluate all powers that I see, which means I need to evaluate this exponent. I need to evaluate this exponent. I can't evaluate this. I have to solve for this, okay? So in my next line of work, the x squared is just going to come down for the ride. And utilizing my calculator, I'm going to evaluate what 7.4 squared is. So 7.4 squared should give us 54.76. So I'm going to say plus 54.76. Notice how my exponent's gone there. And I'm going to do the same thing for 12.8 squared. 12.8 squared should give us 163.84. All right, this is where our steps are going to differ. If I want the value of x, that means I need to solve for x. I need to get the x alone. So the first thing I need to get rid of is this number, okay? So I undo the number that's being added first, and then I undo the exponent of 2. It's kind of like a two-step equation. So in order to undo that plus 54.76, I'm going to do the opposite operation, and that's to subtract 54.76. What I do to one side, I must do to the other. I'm going to do it over here as well. These go away on the left. I still have an x squared on the left. I bring down my equal sign, and on the right, I subtract. Always do the bigger number first. 163.84 minus 54.76 equals, this is what I'm getting in my calculator, 109.08. Notice how I'm waiting to round to the nearest tenth at the very end. I'm not doing any rounding while I'm solving. All right, so now, just like last time, in order to get the x by itself, I take the square root. What I do to one side, I do to the other. These are going to cancel. I have x by itself. And now I'm going to take the square root of that answer. Here's what I'm getting in my calculator when I do that. I'm going to write a few decimal places first, and then I will round it. I'm getting 10.4444 1, and it just keeps going. It doesn't repeat. The 4s aren't repeating. It is changing when I read this entire number. But again, if I want to round it to the nearest tenth, I look at the 4. That's just to the right of the decimal. And then I look to the right of that. It's 4 or less, so I let that 4 rest. I'm going to leave it as 10.4. I don't include any of the other numbers to the right. This is my final answer. And those are the two different types of problems that you're going to do on the homework. Problems like number 2, where you find the hypotenuse, and problems like number 3, where you find a leg. I'm going to do 2 more problems just to kind of review with you, and then we will call it a day for this lesson. All right, so start by finding the 90-degree angle, go diagonally across, find the hypotenuse. Here's my C value. A and B are the other 2 values. I'm going to start by writing my theorem. Notice I'm trying to go a little faster here. If I'm going too fast, pause the video, rewind it. And of course, if you're confused about anything in the video, you can always reach out to me. Email, Google Classroom, I'm around. All right, I'm going to substitute values in. A squared, well, I said A was my 6.6 with a little exponent. X squared is going to replace B squared. 7.4 squared replaces C. So I'm looking for a leg again. So this is one of those problems where I'm going to have to do a little more work. First things first, I'm going to evaluate those exponents. 6.6 squared is giving me 43.56. I'm going to bring down my plus x squared equals, and I'm going to evaluate the other power. 7.4 squared is giving me 54.76. And just like last time, I want to get the x by itself. So there's a couple things that I need to get rid of. I need to get rid of the 43.56. I got to do that first. And then last, I'll get rid of that exponent by taking the square root. To get rid of a 43.56, well, look to the left of that number, right here, where my highlighter is. Do you see a plus or minus sign in front of that number? If the answer is no, it's understood to be positive. To undo a positive number like this, you're going to subtract it. You always do the inverse of what we see here. What I do to one side, I do to the other. These go away. X squared is alone. And in my calculator, I'm going to subtract 54.76 minus 43.56 is giving me 11.2. Last but not least, I got to get rid of that exponent on the x. Take the square root to cancel out the square. Do it to both sides. And if I take the square root of 11.2, here's what I'm getting with a few numbers. 3.3466, and then it keeps going with a bunch of random numbers. So I want to round the number just to the right of the decimal, which means I'm going to look just to the right of that. It's a 4 or less, so I'm going to let that 3 rest. 3.3 is what I'm going to write, and I'm not going to write any other numbers to the right of that. This is my final answer. Let's do one more. Draw a line diagonal from the 90-degree angle. There's the hypotenuse. That means the other 2 values are the legs. And look at that, we know both of them. That means for this one, we are finding the hypotenuse. I'm going to start by writing my theorem. A squared plus B squared equals C squared. I'm going to substitute my numbers in. 4.3 squared plus 14.1 squared equals x squared. And I'm going to evaluate my powers. 4.3 squared gives me 18.49 plus 14.1 squared is giving me 198.81. Whoops, let me try that again. 81 equals x squared. I'm going to add these two numbers together. Here's what I'm getting in my calculator, 217.3 equals x squared. And last but not least, I'm going to take the square root of both sides. These cancel. I'm left with x. With a few decimals before I round, this is what I'm getting. 14.741 blah, blah, blah. So if I want to round to the nearest tenth, that's going to be the number just to the right of the decimal, which means I look just to the right of that. It is 4 or less, so I let that 7 rest and I don't include any numbers to the right of it. Here's my final answer. I don't think we bumped up any of the numbers. All of them we left the same. And that is our little review of the Pythagorean Theorem. So give the homework a try. You've got different options for how you can submit it to me. I think the easiest way for you guys would be to print out the homework if you've got a printer at home. Do it on paper. If you don't have a printer, no big deal. Just do the work on lined paper. Snap a photo of it and upload that to Google Classroom or email it to me. If that is proving to be too difficult, if you don't have a way to take a photo of it, you can also do everything electronically. If you go to Google Docs, you can type out your answers. It's going to be a little bit harder to show all of your work. This is a learning experience for all of us, so please feel free to reach out if you're running into any issues. Take care.